Hopefully it's recording. We'll see here. All right, so in the textbook, everybody's read the chapter 1, right?
Yeah.
You memorized it?
100%.
100%. So I don't need to put a quiz in about this book, right?
No.
The quiz is only on the other chapter?
Yep.
And I made it easier? Did you guys take it? Okay. Some of you have. Some of you said,
You have to read this chapter to do the homework anyway.
oh, what a mean person I am. You have to read the work to do the
I'm
homework.
just telling you, you don't need to have a quiz because we clearly read it.
Oh, if you did the homework. So what about those people who didn't turn in the homework?
Who haven't turned it back yet? Don't do it.
True. True. All right, so a couple of things in here we want to talk about. So one of the things that I really like about Python is it has a lot of references to strange, obscure things from a comedy troupe. What comedy troupe am I talking about? World's greatest set of movies? Oh. Monty Python. Monty Python and the Search for the Holy Grail. Possibly the greatest movie ever made. So there's a lot of references you'll find inside, little Easter eggs and things. So there are a lot of fun things. And in fact, on your final, knowledge of Monty Python is important. There are a couple of questions on your final about Monty Python. So one hint might be one of the Monty Python members actually went on to become a physician. Might be handy to know which one. Some have become respected actors. So, why did we pick Python? What's one of the reasons we picked Python? It's free. That's as good a reason as any. It's free. It's Englishy. Yes. It is Englishy. It is an object-oriented programming language that we don't always have to use the object-oriented features for. So we can write very simple programs if we need to. It's used for a lot of really great scripting tools, but it also can branch out and do an entire project. So, anybody in here use Dropbox? You've heard of Dropbox? You've heard of it? You've maybe used it. It's actually written in Python. There's a lot of software that's actually written in Python. It's a great language, and hopefully will get you introduced to this idea of what we can do, what kind of powerful things we can do. Right now, we've managed to create a print statement, and we're going to talk about a couple of those. But it's pretty simple to start with. So, there's all different kinds of languages. If I look online, you can easily find 600 plus different programming languages. Some of them are easy to use, some of them aren't. This one is fairly easy to use. It isn't as easy as some of you may have used in high school, something called Alice. Did any of you guys in here do that? No? Alice literally has modules you snap together with a mouse and a cursor. But it's not very useful for actually writing code. I actually got to see this in use. So, for example, companies like Google, when they're monitoring their servers, they'll write scripts in here. We do a lot of Python in cybersecurity because we can write scripts in Python. So if you're watching a movie about anything about cybersecurity and they start whipping out a script, most likely what they're doing is actually writing it in Python. We can interact with things very, very quickly in Python. So it's got all these fun things. It is object-oriented. It runs on nearly anything we can possibly do. Every kind of computer platform. Windows, Mac, and I know we have quite a few Mac users. The Mac version looks almost like the Windows version. There's Linux, you can run it on tablets, you can run it on nearly anything. So, free, open source, cheap, we can get it. It's got a lot of documentation. So the other piece that I think is really important is there is a lot of documentation about what to do with it. There are tutorials. There are hundreds of websites out there with tutorials. So when you get stuck, and I'm often somewhere in sunny California and deciding to go vacation for the weekend, I have these dreams every once in a while, and I'm not around or I don't answer your email in 2.7 minutes, there are enough resources you can get through this or any class. We can build web browsers out of Python if you really wanted to get into that. So we're going to go through a couple of things, and some of you have already turned in the homework, so you're already partway there. Some of you haven't. So one of the keys to this is when we are doing this class and you're looking in this book, you have to work through these examples. You have to do it. There's no other way to get around it. You have to get your fingers on the keyboard. So I'm not even going to ask what's going on over in the corner. So I'm scared to know. So I'm going to start by you start with the idle. And idle will pop up. And this is this a script or interactive mode? Script or if I'm thinking about a script, a batch script is something I can run in an entire group. This is the interactive mode. So this is useful if I just want to do a simple thing and I want to see if a command exists. So if I want to see if print exists, hey, it does, and I can print out some kind of comment. And it works pretty good for that. Almost always, though, the script mode, so here I go, new file, and so it almost looks like a text editor, and it really is, and I can put my content in there. And really right now all we know is a print statement, so we'll play around with that a little bit. So we've talked about functions and methods. Print really is a function. It's a function built in to Python, but it's a function, and we put in content inside these parentheses that sends it to that function. And so Python goes, oh, okay, now I get this content, I'm going to put it into my function. The print function says, oh, I'm going to put it back out on the screen. And so it doesn't do anything truly exciting, it just echoes it out to the screen is essentially what it does. So notice that it changes color and says, hey, you probably are on the right task. But we can try to do some experiments with things. So what do you think is going to print when I put 1, 2, 3 plus 1, 2, 3 in there? Well, let's find out. And in fact, because I know I've got this interactive mode right there, I don't have to save it. I can just try things. I can put that line in over here, and I can say, all right, what is it going to do? So I could say print. Oh, it actually added them up for me, didn't it? So if I wanted to print that, I would actually have to, if I wanted to print that as a string, I would actually have to change that so it had quote marks in it. So quote marks tell it to print exactly what's in there. This says, hey, it must be a number. So we already start to see it can work on a couple of different items there. It can work on numbers. It can work on other items. So page 8 out of our textbook talks about the idea of that print statement. The bottom of the page talks about that return function and how it works. So once you complete your homework, you become a programmer. You've now written a program in some form of a language. In this case, you've written it in Python. Over here, if I make a mistake, I don't see it right away. But we're going to take a look and see if we can. So I'm going to run my module. It says, yes, I need to save it. And remember, this is where you do need to find a spot that you're going to save those files every time. So I'm just going to call this test because we're going to do it with a test quite a bit. And it gives me an error. And so I'm going to look at my code, and I'm going to look at this error, and it says name A123 is not defined. So when I accidentally typoed and I put that A in there, the program doesn't know any better. It says, well, I'm going to try to find this. It must be a variable, and it's going to give me an error, and it says undefined. So if I could solve that in a couple ways. I could fix my typo. I could also try doing this. What happens if I put just a variable and I say A123 is equal to 13 or some number? So again, we're going to experiment. And so when I do that, notice it fixed the error and it actually ran. So that's our first introduction to a variable. Now, that isn't what I necessarily wanted to have happen. But it shows me that variable. And now I have a variable. Is it used for anything? No. So I'm going to delete it. So one of the keys, though, in this class is I need to find out who you are and what your material is. So at the beginning, we need another thing, and that is we need comments. So I'm gonna hit this over and over again about putting in comments, and I can guarantee the first time next week when we assign a programming assignment that you submit as a .py file, half of the class will not put their name in it. That's been my experience. Make sure you put those comment tags in. So name, assignment, they're free. They don't cost anything. So pages 10 and 11 talked about script versus interactive mode. So make sure you have read that and went through the material. What is the advantage of script mode? What is the advantage of interactive mode? Again, if you did the homework, you should have already read that. So we have a couple of things that we need to work on. And there's one weird thing we need to look at. And that is, at almost any program, we have a weird little issue. And I'm going to save this one in a strange spot so we can see it easily. I'm going to save this one as test, and I'm going to put it on my desktop just so we can all see it. Yep, there it is. I'm going to replace it. And if I go to my desktop, I can see that test is right there. So these programs do run inside of Windows. They don't have to run inside that idle environment. It'll actually run. And there it went. Oh, what happened? Well, let me run it again. Why does it just pop up a screen and die? Well, here's the reason why. Go back to my idle windows. So as this program runs, so it comes through and it says, Brad, it prints out a print statement and it prints this number. And it's done very, very quickly. It gets done with that. And by default, when I just run this program and it says, you're done running, you're going to close for me. Well, we don't necessarily want it to close. We want to keep that window open so we can see what happens. And so at the bottom of every program we're going to write, and it serves this purpose, is we're just going to write a fake input statement. So we're going to put an input statement. And an input does take an argument, so we can put an argument in. And so we're going to do a couple of other things. So I've got a couple of /n's that we don't know what they do yet. So we took in an input statement, and all that input statement does is wait for you to press the enter key. So I'm going to save this. And notice I have an error when I did that. And that error when I ran it, I didn't end that. So when I did that, notice everything is still green. So you need to make sure you look at all those end tags, just like you do in web design or other courses. So we're going to run this now. And over here it says this is a print statement. Press the enter key to exit. And then when I press the enter key, then it goes back to my little indent lines. If I run it from the desktop now, notice the difference. Now it actually says, hey, it's a print statement, gives me the number, holds it up on the screen, and when I click that enter key, then it disappears and exits. So the whole reason we do that is just to keep that program open without ending it. And so now I can run my program. So I could send that to somebody and they could run it. And they don't necessarily need then to have the entire environment open to be able to do that. So we can create them that way. That makes life a little easier for us. So that is one thing we need to put at the end of every program. So here is a thought that might be a great idea. What if I did this? So I'm gonna put this one over to the side. And I'm going to file new. And I'm going to do a couple of things in this brand new program. I know that every program is going to start out with at least my name, 210, and so I'm going to make my own template. And as we get more items in here, you can add items to this template. And so I'm going to put in that input statement, so I don't have to retype it every time. I'm going to have it here. And then I'm going to save this as, I'm in my documents, files. I am going to, wherever I'm going to save my files, I'm going to call this my class template. And so now, rather than starting every time with a blank slate, I can go in and I can open that file. And so I can open it in a variety of different ways. And one of the ways we can do that, so documents, Python files, if I just right-click this file, so class template, notice I have the edit with idle right there for me. And I can open it that way. So it's a little extra step, but now all that material is in there. And as we get bigger files and we get more content, creating a template for you to start with is actually a really great idea. This gives you all the things you need. You won't forget to at least put your name on it. You need to go in and go assignment number 2 or whatever it is. But as we get bigger, you'll start to see we can have other things in there. So one of them we might have some imports. So notice import turns orange. And you're going to find out we import other things in. So print function is already imported in for us. But there's some that aren't necessarily in there. So maybe we need to import the random library. Or maybe we want to import a file system or some other thing. I could then keep those in that template and I don't necessarily need to have them anywhere else. So this is just a helpful hint how to try to save you and make your life a little easier. So these templates, as we start going, like I said, you'll start adding more items to them. But it really gives you a way to start out and get a nice structured element. So every program we're going to run in this entire class is going to end with this. So if it's in there, then I don't have to yell at you for not having it in there. So I've just built that little template. Yes, I want to save changes, whatever it is. I have to be able to know where I'm saving them. And that is always a struggle for some of the students is where are we saving our files? So again, if you're in here and you're using multiple computers, you probably should be doing it on a flash drive. You certainly can try to email yourself files back and forth, but one problem with that, these are program files, and a lot of email applications are going to kick it back and say, nope, I can't send that file. That file could be corrupt, it could have a virus, it could be whatever. So a flash drive or some other place you're storing that is a really great idea. Then you can work on it virtually anywhere. I'm going to close that out. So, a couple of different modes. This is actually kind of your short week in terms of content. You've got to finish up chapter 7, so there is a quiz on that. And there is this program. And we have all of the comments and everything you need to do that right now. The only thing we haven't talked about is the idea of white space, and we're going to throw that in right now. My program doesn't care if it looks like this. That program is going to do exactly the same thing with white space or without white space. Use it to try to break up your elements so that you can see what's going on. If I run this right now, it's going to look exactly the same. I put in white space. Now, when I say white space, I'm talking about vertical. If I do this, let's see if we can make it hiccup. Notice what it does. I can't just randomly indent. There are some rules about my indenting, but vertical white space is free. And it yelled, it said, I don't know why you're indenting this. That doesn't make sense to me why you're indenting. But when we start creating loops and other things, then we'll need to indent and indent in these blocks. So white space is free, use it. Comment tags, don't impact it, use them. But I can do this without deleting anything. This program, when I run it, runs exactly the same. For the size of our programs, it's not going to make any difference. And if it makes your life easier to go in and look at it, and if you put in things like comment tags, below is a test print, we discovered it actually added them. Because if what you were trying to print on the screen was actually to show this, that would be a far different problem. And that would show that particular result. So we need to be careful of those. Make sure you stop at your ending tags, or if you don't forget to end one, it will error and say, oh, no. In this case, it says the error is actually on this line. But the reality is the error is here, but it thinks that this is then part of that line below. So ending pieces are one that I see people struggle with all the time, is making sure that you end these. So one last thing I will say here. When you turn in an assignment, the first thing I do is try to run it. So if you couldn't get it to run, don't turn it in that fashion. Ask for help, ask for ideas, ask for thoughts. Use that instructor's corner. Now, the other piece that it tells me is sometimes if you don't get it to run, that you did it last minute, you didn't spend the time and work on it. This class is going to take you some time to do. Some of these programs are going to drive you a little bit insane. You're going to be staring at it. If you don't give yourself some time, it's harder to do. If you have that ability sometimes to walk away, take a break, go get something to drink, get a cup of coffee, take a walk around the block, go pet the dog, whatever it is, and then you come back and look at it, sometimes you'll see those things that you didn't see before or weren't able to find that error in your program. These kind of things like syntax, well, they'll give themselves away eventually. But when we have logical errors, the logical errors are the harder ones to track and to trap. So, just kind of my word of warning about start early, start often. Try these things. Experiment. There is nothing you can do in Python to completely break your computer, we hope. No. There really isn't. You're in a controlled environment. Unless you have managed to start writing something like a Stuxnet virus, there's nothing you can do that will really hurt anything. So, this is probably the shortest assignment you will have next week, so make sure you start reading ahead. When you do these things, you really do need to try the code that's in the book. You need to sit down, try to do it, see if you can make it work the same way. And if you're not, then let's figure out why you aren't able to get that code to work. Because if you can't get the code to work in the book that we already have examples of, then it's going to be really hard for you when you need to create your own code. And we need to make some changes that way. Does that make sense? All right.